Hi class, we're continuing our notes on oxidation numbers and redox reactions. Now we get to kind of apply why it is we even talk about this. Well, there's a special type of reaction that involves the changing of oxidation numbers. So you need to know what an oxidation number is to be able to determine how the electrons are moving and flowing through a reaction. This is the science behind batteries. It's how batteries work. And there's lots of other applications too. Oxidation reduction reactions, also known as redox reactions, you can kind of see we have ox and read in the name. Redox, reduction, oxidation, oxidation, reduction, two different words for the same thing. They're reactions that involve the transfer of electrons. We've got two different terms you need to know, okay? One of them is oxidation. Oxidation is the process of losing electrons, or the increase of oxidation number. It becomes more positive. Oxidation is losing electrons and becoming more positive. Reduction is the process of gaining electrons, and it's the decrease of oxidation numbers. The reason I write with red for this is because a lot of times we will abbreviate these RED for reduction and OX for oxidation. So let's go through just a couple quick acronyms. You can pick the one that works best for you. It's just ways of remembering which is which. Leo the lion says grr. So Leo says grr. Leo, losing electrons is oxidation. Says grr. Grr is gaining electrons is reduction. And then we have oil rig, which is the way I tend to remember it actually. Oil rig, oxidation is losing electrons. And rig is reduction is gaining. Oxidation is losing, reduction is gaining. And we're talking about electrons. You have to keep in mind, keep it straight, that electrons have a negative charge. So when you gain electrons, you get more negative. When you lose electrons, you get more positive. Note that to be able to determine what's being oxidized or reduced, you have to determine the oxidation number of each atom in the reaction. Otherwise, you don't really know. So we're going to do some examples and some practice. Okay, so looking at this, sodium, it's by itself, it's just got an oxidation number of 0. Chlorine, again, just a monatomic element, or it's diatomic element, but it's just one type of atom. It's 0 because that's not a 6. That's supposed to be a 0. Because there's no charge written and it's not in a compound. But then I get to NaCl where there's a compound. Na is in group 1, so I know it's positive 1. That means that chlorine, in this case chloride, has to be negative 1 in order for it to be neutral. Okay, now we're looking at the change that happened. I see that that sodium went from 0 to positive 1. Now that was a positive change. It became more positive. I also see that chlorine, it went from 0 to negative 1. That's a negative change. It became more negative, which is reduction. So let's see, the element being reduced would be Cl. Cl became, it went from 0 to negative 1. And that's the way that I want to show work. Okay, which one was oxidized? Well, that was sodium. Na was 0 and it became positive 1. All right, I'm going to cut the video right here. We're going to do a few more examples.